Good afternoon, students. This is FBA 310 Statistics 2, the second lecture. My name is Dr. A.I. Opara. Now, in this lecture, we'll try to complete our discussions on the normal distribution, which was disrupted during the first lecture we had. We have told you earlier that the standard normal distribution is presented as this bell-shaped curve. You can standard normal, while probabilities under the standard normal distribution is an area. For instance, this is an area that Z is less or equal to A. So let's see how to use the standard normal distribution 0, mean 0, variance 1 to find probability that Z is less or equal to 1.5, probability that Z is less than minus 0.56. Let me clarify here. The probability that Z is less or equal to 1.5 is the same as probability that Z is strictly less than 1.5. The equality contained in the inequality doesn't matter at all. How do we find probability that Z is less than 1.5 for a standard normal distribution? Please bring out the statistical tables and open the page for standard normal distribution. I'll give you some few seconds to do that. If you open that standard normal distribution table, by the left corner of the page, the first column on the left side, the first column ever, is the column that contains the values of Z, which starts from around minus 3.5, increasing to minus 3, increasing to minus 2.5, to minus 2, and so on, up down to 0. Now it starts then increasing from 0 to minus 0.1, minus 0.5, up to 1, 2, 3, then up to 3.5 and stop. Now, probability that Z is less or equal to 1.5, we go and look for where this value of Z is 1.5. Then we read under 0, 0, that is, at the top of the table, you have values 0.00, 0.01, 0.02, 0.03, and so on. These are the second decimal points, of the Z value. In this 1.5, there's no second decimal place here. So we read under Z equal to under 0.0. So, sorry, we read 1.5 under 0.0. So that value is 0.9332. Now, how do we find probability that Z is less than minus 0.56? When we go along the Z value, we find minus 0.5, we won't find 6. So we read minus 0.5 under 0.06 on top to accommodate these values. So we read at minus 0.5 under 6. You remember how we read values at your log writing tables in high school, the same thing. We find out the value is 0.2877. What of probability that Z is greater than 1.528? First of all, correct this value to the nearest two decimal places, which is now 1.53. Now, probability that Z is greater than 1.53. Remember what we did under the binomial and Poisson. This is equal to 1 minus probability that Z is less than 1.53. So the value of Z under 1.5 under 3 is 0.937. So you then subtract that value from 1 and get the answer. Probability that Z is 0.9 is equal to minus 0.60. This is because we told you that the probability that the normal random variable, whichever one, is one value is 0, because we can only find probability that z lies in an interval. Probability that z is greater or equal to minus 1.27 and less than 2.33 is, look at probability under z being less than 2.33, subtract probability that z is less than minus 1.27. These are the values you get, and then when you do the subtraction, you get 0.8851 as the answer. Again, we can have a normal distribution which is not standard normal. For instance, this normal distribution x has mean 60 and variance 81. We can't use the normal table to find this. We have to change x to z. How? See how we do it. If x is distributed as normal mean mu and variance sigma squared, then if you subtract the mean from x and divide the quantity remaining by standard deviation, we call it a transformation. All this quantity now we have, its value is z. How do we apply this? Let us, under this normal distribution that x is normal 60, 81, let us find probability that x is less or equal to minus 45. First of all, we change x into x minus mean over standard deviation. We also change 45 into 45 minus mean over standard deviation. This gives us probability that z, this quantity now is z, is less than this. That value upon simplification is minus 1.666, which you correct to 2 decimal places to be minus 1.67. And when you look up top at the table, minus 1.6 under 7, that probability is 0.0467. The probability that x is greater than 69, you transform both x to this quantity and 69 to this quantity and do the rest. Probability that x lies between 51 and 69, you change x to this quantity, then 51 to 51 minus 60 over 9, and 69 to 69 minus mean, which is 60 over 9, which is standard deviation. This quantity is now z, which is lying between minus 1 and plus 1. So, which is probability that z is less than 1, minus probability that z is less than minus 1. Then you get these values, which is the answer. Normal approximation to the binomial. We have before told you that the Poisson distribution can be used to approximate the binomial, provided p is very small. But when p is not very small, look at here, p is 0.25 and n is large. We use the normal approximation. Now, if we are using the normal approximation, what is the mean of this normal distribution now and the variance? The mean is now NP and variance is NPQ. Now, this mean NP is 60 times 0.25. That's the answer. Variance is NPQ, which is 60 times 0.25 times 0.75, which is Q, which is 112.5. That is the variance. Then standard deviation, which is square root of variance, is square root of 112.5, which is this quantity. So you find that this binomial random variable x is between 130 now to 155. We have changed it to z now, that this z, which is now standard normal, then this 130 is transformed to standard normal by subtracting 150 from 130 divided by standard deviation, and then 155 transformed to 155 minus 150 over this. Then you complete the problem. This is how far we can go. Thanks for listening. The end of the lecture. Thank you.